PH261, Chapter 4, Homework Problem number 6. A stone is catapulted at time equals 0 with an initial velocity of 18 meters per second at an angle of 41 degrees above the horizontal. Neglect air resistance. Find its horizontal and vertical displacements from the catapult site at the following times of launch. So, we are given the initial velocity and the angle. And is this enough to judge everything else? Well, let's see. So for our projectile motion equations for x, we have change in x, which is what it's asking. We have v0x times t. And for y, we have v0y times t, but then it's minus 1/2 gt squared. So all we need to know here is the time, which is given for each of these, and then the initial velocity. Now for x and y, we can just note that cosine theta would be x, and sine theta would be the y. Just what sine and cosine would be here. So from this, we can say that for our A horizontal, it would be, let's just do B here and C here. It would be (18 cosine 41 times t, which is times 1.2. And that is 16.3. Same thing with b, it's going to be 18 cosine 41 times 1.6. And that is 21.73. 18 cosine 41 times 2.42. That is 32.87. All right, so that's all of the x directions. Now let's do the same thing with our y. So, with our y, or vertical, we can make note of that really quick. That horizontal is x and vertical is y. We would do, for A, it would be 18 sine 41 times 1.2 minus 1/2 times 9.8, because that's the acceleration due to gravity, times 1.2 squared. And that is 7.11. Now let's do B. Again, 18 sine of 1.6 minus 1/2 9.8 times 1.6 squared. Let's see what this would become. I'm getting 6.35, and then for C, 2.42. I'm getting, well, 18 sine 2.42 minus 1/2 9.8 1.6 squared, or 1.6 2.42 squared. I'm actually getting a negative number. Now, if it's horizontal and it's going up and it's coming back down, it can't, unless there is a hole in the ground, unless there is a hole, which there isn't, then it really can't be lower. So it just impacts the ground. So instead of it being negative 0.11, what it really is 0. And that is how you do this problem.